Good evening, everyone. Welcome to our first day of summer class. Today, we're going to discuss the Pythagorean Theorem. First, let us review the right triangle. A triangle is said to be right if one of its angles is a right angle, which is 90 degrees, and the two other angles are complementary, which means the sum is 90 degrees. This is our right angle, then the sum of these two angles is 90 degrees. It has a base, the horizontal side, an altitude or the height, which is the vertical side, and the hypotenuse, which is the longest side of the right triangle. To solve for the sides or the length of the sides of the right triangle, we will be using the Pythagorean theorem. The Pythagorean theorem, so here's a brief history of the Pythagorean theorem. So the history came from XP geometry book. The Pythagorean theorem says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So A is the side of square on the base, B is the side of the square on altitude, and C is the side of the square on the hypotenuse. Okay, so this means that when we get the square of A plus square of B, it is equal to the square of C. So that's A squared plus B squared equals C squared. By commutative property of equality, we can say that C squared is equal to A squared plus B squared. Okay, so when we need to get A squared, that is C squared minus B squared. B squared is equal to C squared minus A squared. To get the value of C, A, and B, we have to get the square root of both sides. Therefore, C is equal to the square root of A squared plus B squared, and A and B is equal to the difference of C squared and the square of the side. Okay, let us have an example. Find the unknown side or the length of each triangle. Okay, triangle number 1. Altitude is 1, the base is 2. Now we're going to find the hypotenuse. Let us draw our triangle here. Okay, so this is 1 and this is 2. We have to find x. Okay, so this is our altitude. We can name this as A. Then this is our B. We can name this as, or the base, we can name it as B. Now we're looking for x, which is the hypotenuse or C. So how are we going to find the value of C? Of course, we will be using the Pythagorean theorem. C is equal to the square root of A squared plus B squared. Going back to our triangle, A is 1, B is 2, and C is x. Substitute the values that we have here to our formula. So C is equal to the square root of 1 squared plus 2 squared. So if you know how to square particular numbers, you can write it here. 1 squared is 1 times 1. So that is 1. Plus 2 squared. 2 squared is 2 times 2, which is 4. So C is equal to the square root of 1 plus 4, which is 5 right here. Okay, so C is equal to the square root of 5. That's how we're going to get x. Therefore, C is equal to the square root of 5, and we know that x is C. Therefore, x is equal to the square root of 5. Next example. Again, find the value of x. So we have our triangle. This is not a right triangle. When we draw an altitude from here to here, now we have two right triangles. And we have to find x. How are we going to solve for x here in this example? First, let us draw our triangle here. Okay. So here's the altitude. This is 10, 6, 15, and x. So first we have to find the length of this altitude. Okay, so we will be using the Pythagorean Theorem dealing with the smaller right triangle. We will be solving this first. Okay, so let us have this as C because it is our hypotenuse, 10. Then 6 will be our base. So B, we are looking for A. So A, from our formula, is equal to the difference, square root of the difference of C squared and B squared. Substitute the values that we have. So A is equal to the square root of C is 10. So that is 10 squared minus 6 squared. Okay? So A is equal to the square root of 10 squared minus 6 squared. 10 squared is 10 times 10. 10 squared is 10 times 10. So that is 100. Minus 6 squared. So that's 6 times 6, which is 36. So A here is equal to the square root of 100 minus 36. Okay, 100 minus 36 is 64. And the square root of 64 is 8. Therefore, this altitude here is 8. Okay, now that we know the length of the altitude, which is 8, and the base of the other triangle, which is 15, we can now get x. So this becomes our A, this is our new B, and this is our new C. This is for the second triangle, so we can get the value of x. Okay, so for the second triangle, let's solve for x. So this is the unknown, so we will use the formula for C. C is equal to the square root of A squared plus B squared. C is equal to A squared, so 8 squared plus B is 15. 15 squared. C is equal to the square root of 64 plus the 15 is 225. Okay, so C is equal to 64 plus square root of 64 plus 225. 289. And 289 is a perfect square. The square root of 289 is 17. So C is 17, therefore X is equal to 17. Okay, now I will be giving you other activities for your practice. Then later, or for the next video, I will show you how to solve it. How to solve them. For your practice, number 1, find the unknown side length of the triangle. This triangle. Okay, so the hypotenuse is 10. The altitude is 8. So you're going to find or to look for the value of the base, x. Number 2, find the value of x for this quadrilateral. So the length of the shortest side is 6. This side is 12. And this is 10. Now you're going to look for the length of or for the value of x. And for the challenge problem, on sides AB and CD of rectangle ABCD, points E and F, respectively, are chosen so that AFCE is a rhombus. If AB equals 3 and BC equals 5, find EF. Later on, I will be posting the solution video for the solution of the practice problems or practice questions. So for now, please answer the 3 questions for your practice. I'll be right back after an hour. Thank you.